to part 2 of LLMs. And here are our objectives. We've got a lot more here. So I want you to expand your understanding of how complex large language models are. So I want you to learn a little bit more about how they work. We know that they predict the next word to make a plausible but not necessarily truthful response. But let's learn how that exactly happens, or not exactly, because it's actually wildly complicated. But let's learn a little bit about that. And then let's grasp exactly why it is the case that LLMs will always hallucinate, which means have moments where they produce false or nonsensical responses. Then let's talk about how to be a responsible user of LLMs. So some of the questions you might be looking to answer as you take notes with your pencil in your hand, handwriting, is how do LLMs work? What are some exciting possibilities that LLMs afford? And what are some inherent problems with LLMs? And then maybe throw something in there. How can you be a responsible user of this technology? So here we go. You are not going to walk away from this with a perfect mental picture of what's happening inside ChatGPT, just by the way. And that's actually fine, because literally no one has that picture, not even the people who made this technology. That's part of what makes this technology so fascinating and frankly scary as hell. But you can take notes and draw pictures and see how much you can challenge yourself to understand. So the point is really just to show you how complex this is so that you can have an appropriate awe and maybe a little bit of terror about this. So large language models work by using neural networks to do some of the work of predicting their responses. And what is a neural network? At its most basic, it's a computer system loosely inspired by the way brains are organized. But I want to be clear, it is inspired by brains, but it doesn't work like a brain. Not really. A neural network is fundamentally a statistical pattern. It takes input, and in between, it produces output, and in between, it has learned through exposure to enormous amounts of data, to get better and better at predicting what the right output should be. So the structure looks a little something like what you see on the screen. There's an input layer that receives information, that's your prompt, and there's an output layer that produces the prediction. Though it's not just your prompt, it's your prompt converted into some math, which we'll see in just a second. In between, there are hidden layers, sometimes many of them. And in ChatGPT 3 and 4, there are over 100 different layers that this information from your prompt goes through before you get an output. The neural networks used in generative AI are called deep neural networks because there are so many of those hidden layers stacked on top of each other. And that's actually where the term deep learning comes from. But here's where it gets interesting and a little strange. Neural networks are systems built on math. They work with language, but language is not numbers. Words aren't numbers. So how does a system that only understands math work with something as messy and human and contextual as language? The answer is something called word embeddings. And here's what that means. Every word that an LLM gets from your prompt, it gets converted into a long list of numbers, and not just one number, a list, each number representing a different dimension of that word's relationship to other words. And this is called a vector. And what these vectors capture is not just what a word means in isolation, like water means H2O, but it looks at what that word means in relationship to other stuff. So say we wanted to represent the word water, the LLM will take that word and turn it into a vector of literal coordinates. So numbers like your Cartesian plane and basic kind of geometry. And it will make it into a vector of coordinates in a multi-dimensional space. Okay, so already we live in 3 dimensions. Multi-dimensions are, even more than 3, right? So, and then it can reason how far a certain word is from another word. So water might be placed near ocean since they appear in similar contexts. However, Water might be also placed next to something like life, because in many cultures and in many sort of religious and spiritual traditions, these two things are linked often. So there are lots of different relationships that words have to one another. And some of those dimensions are really capturing important stuff like grammatical information. Like, is this a noun? Is this a verb? But some of those relationships can capture meaning. So what the word refers to in the world. Some of those relationships might be about tone. Some of those relationships might be about context. But here's the part I find genuinely mind-bending. We don't know necessarily what all these relationships represent that the computer creates. These researchers build systems, but we cannot observe all those different dimensions and all the different relationships that these large language models are making between language. We can know that they're creating these relationships with numbers, but we don't exactly know what all relationships they're creating. And this is why AI is called a black box. The system is working in a space that is not three-dimensional, that is not four-dimensional. It's operating across hundreds of thousands of dimensions simultaneously. And this multi-dimensional space allows it to detect patterns between words and concepts that are extremely subtle. Patterns that emerge across a huge body of text in ways that human readers, reading one thing at a time, might never consciously notice. So I want us to think about that for a second. The system is finding relationships between words and ideas in a space that our minds can't even visualize. In that sense, it's doing something genuinely beyond normal human pattern recognition. It's not that it's smarter. It's that it's operating at a scale and in a geometry that's just completely different from how we think. And this is where I want to share something I find both creative and somewhat cautionary about LLMs as creative tools. Because the LLM is working in this abstract multidimensional space, it can make connections between ideas that are genuinely unexpected, connections that a human writer might never make. Not because they're not smart enough, but simply because the human brain is not able to run that same kind of calculation. So in that sense, LLMs have a real creative use. They can surface hidden relationships, unexpected angles, novel combinations. Used well, they can push your mind further than it may have gone on its own. But here's the problem, and this is a real one. The connections that are being generated by a system that doesn't have human meaning as its organizing principle is potentially problematic. It has statistical patterns as its organizing principle. Most of the time, those patterns align with meaning, but sometimes the connections that it surfaces doesn't quite land for a human reader. It seems interesting, but it turns out to be shallow. It sounds profound, but it doesn't really hold up. It's making a move that works mathematically in a vector space, but does not translate cleanly into a human space. So I kind of just wanted to add some cool art. Neither of these were generated by AI. Both of these are human. So this is a really cool artist named Yayoi Kasuma, and she has these cool art installations, these like boxes that you can go inside and look at these kind of otherworldly places. And this is an artist who kind of does some creepier stuff. Well, I'm not going to try to pronounce that name, but the point is that like humans do really creative and wild stuff, but it always refers back to some kind of something that has to do with humanity. And that's maybe not necessarily always going to be the case for AI. So, before I go there, I'm going to say, when you use LLMs for creative or intellectual work, what you're doing is having a conversation with something that operates in a fundamentally different mode than you do. That is not a reason to avoid it, but it is a reason to stay in the driver's seat. You are the one with human judgment. You are the one who can tell the difference between a connection that's genuinely illuminating and one that just sounds good because the math worked out. And that distinction is what we are here to develop this semester. among other things. So this multidimensional non-human creativity is also partly what accounts for the fact that AI is always going to hallucinate. So I want us to say this is from the New York Times. This was last year, but the architecture of LLMs have not changed. So the response and the reality of this remains the same. As AI gets powerful, its hallucinations potentially get worse. And as we see, kind of some of the reason that might be is because with more information, it's able to make more novel kind of connections, which may or may not actually be true or helpful for us. So let's read the text of this. Today's AI bots are based on complex mathematical systems that learn their skill by analyzing enormous amounts of digital data. They do not and cannot decide what is true and what is false. Sometimes they just make stuff up, a phenomenon some AI researchers call hallucinations. On one test, the hallucination rates of a newer AI system were as high as 79%. So it's mathematical probabilities that guess the best response, not rules designed by human engineers. Despite our best effort, they will always hallucinate. That will never go away. So let's bring this home. Given everything we've just talked about, what actually predicts whether a student will use these tools well, or if you're going to get burned by using this tool? Research points to three things, and this is just very new. There's a lot more coming out about this, and this is an evolving technology. So currently, this is what we know. If you have strong language proficiency, if you can learn to write and read well and expand your vocabulary and expand your ability to clearly state your ideas, you are going to get better results out of LLM. If you cannot recognize when an answer is vague or circular or wrong, you won't be able to determine whether or not it's giving you good human-centered information or made up kind of nonsense, useless information. And this class will be part of what helps you develop that. The second is strong academic knowledge. The more you already know about a topic, the better equipped you are to notice when ChatGPT is giving you something that doesn't quite add up. And this is why I'm going to require that you write the first draft without AI and then use AI after the fact to edit. This is always why you should study something first before using AI to help you make better sense of it. Research shows this. You will not learn as much. You will not retain as much. You will not get good results out of AI if you don't know anything about it, something going into your interaction with AI about that thing. And the third, and this is important, is what researchers call high epistemic skepticism. That is a fancy way of saying doubt first, verify second. When you read something, whether it's from Google, ChatGPT, a textbook, or a random website, your first instinct should be to question it, not accept it. I would say really, if it's in a textbook and if it's in a piece of writing that or a resource that your professor or your instructor gives you, you can go ahead and trust it. But if it's coming from an LLM, you want to be skeptical of it immediately and think critically before you accept it. So the practical takeaway from this course is this. Use search engine when you need to find reliable sources to answer factual questions. The results are real things. They're made by real people or organizations. Your job will be to evaluate whether the source sounds credible, and we're going to learn a method to do that. You always have to verify what it is. But what you want to do is you want to use LLMs to extend your existing knowledge. You want to use LLMs to help you work through an idea you've already researched, to assist in maybe drafting or organizing. But the rule is to not inherently trust the output. These tools are not designed to give you truth. They are designed to generate creative, plausible text that is often true, but you're the one responsible for checking. So that's actually a great setup for everything we're going to do this semester. Being a strong writer means being a critical thinker. And critical thinking means asking every time, where does this come from and how do I know it's true? And so let's get started doing all of that stuff.